So we've been leading up to this lesson for a while. What if a line does not fit the data? So what we have is, so far, a least square regression line is really our only option. And on the right here, you can see that we have number of hours afternoon and the weight of dry ice. Recall that Julia's father uses dry ice to keep the glasses in his restaurant very cold. The dry ice evaporates in the restaurant cooler as shown in the table at the right. Recreate the scatter plot and the least square regression line of this data on your calculator. Sketch the residual plot. So what I did was I already went in, I reset my memory, I turned my diagnostics on, I went into stat and I went into edit and I entered a table of data, the same as the table of data that's on the right. And then I went up and did second stat plot. I'm going to turn on the scatter plot. Remember, we want the scatter plot, which is the first option selected. And then we press graph. Now, when you press graph, you're not going to get this. What you're going to get is sort of a blank screen, and you have to remember to do zoom and then go down to option 9, which is zoom stat. And that's how you get the graph with the points. And man, doesn't that look like a really nice fitted line through a series of points? Sure does to me. It looks like your R value would actually be quite high. What we want to do is now go back in to edit our list. Actually, we would need to do stat calc, and we would need to go down to linear regression, which is option 8. And I actually had already done this, which is why mine had a line through it. And I would go down here to store my data, vars. I would go over to yvars, function y1, and calculate. And you can see that I've got my least square regression line, my A value 15.2, my B value negative 0.5. Look, the R and the R square values are super high. And so when we graph it, we get what appears to be a nice fitted line. What we want to do is go back in to edit our table, and we want to go up to L3, and we want to fill list 3 with the residuals, right? That should sound familiar. Because I had list 3 selected at the top, I'm filling in all of list 3 with the residuals. If yours does not pop up that you have residuals as an option, you might have forgotten to turn diagnostics on. You might have not already run the least square regression line. But here's my list of residuals. And now I'm going to change my stat plot. And I'm still going to keep it on. It's still on scatter plot, but this time I'm going to do list 1 and list 3. So I want to change that to second 3, which will give you list 3. And we're going to graph it this time. And you're going to be like, okay, she took away my dots. She kept her line. This didn't work. We can go in and we can turn off by highlighting the equal sign and hitting enter. We can turn off that least square regression line, but we still don't get the data that we want when we press graph. We need to zoom and do zoom stat again because we've changed the dots. And you can see that we now have this curved pattern, and I transferred what I had on the graphing calculator onto my notes. You can now see that the residuals have this curved pattern. And you're like, oh, geez, she's been talking about this for a while, right? So when we did this, we got a least square regression line of y is approximately negative 0.52x plus 15.209. What does the residual plot tell you about the original data? That it's probably not linear, right? This curved pattern. The R was 0.9979. The R squared was 0.9958. Great values, right? We would like to think that it was linear. The data at the right, the table at the right, that really shows what our coordinates looked like, and they still look pretty linear. But because this pattern was curved, that tells us this might be better represented with an exponential function. Use your calculator to determine the exponential regression equation. Use number 0, exponential regression, EXP-REG, instead of option 8. So if I put this back on here, what I'm going to do is I'm going to do a couple things, actually. I'm going to stat, edit. First thing I'm going to do is get rid of that residuals column. All I did was highlight the L3. I pressed clear and enter, cleared everything out of that column because I'm not using those as my residuals anymore. I'm going to do second quit. I'm going to stat, calc, and this time I'm going to go down to option 0, which is exponential regression. And I'm going to hit enter. Same step that I did before where I want to store my data, vars, go right to yvars, and it is a function. And we want to save that function in y1, and then we want to calculate. And this time it gave us numbers that actually don't appear significantly different yet, except when we go to write our equation, you'll notice that it says a times b to the x. So we're writing y is approximately 15.377, the b value 0.959 to the x. The r value got even better, 0.999, but it is negative. And the r squared value, once you square it, becomes positive anyway, 0.9986. I only rounded out that far because 99 doesn't really help me. Is it bigger or smaller? Is it getting bigger, getting smaller? And at what point? So I went out to a few more decimal places to make it a little bit more relevant. Now you can see that I have copied a residual plot onto my page. The question is, how did we get that? Okay, so if we go back into our graphing calculator, now we have a least square regression, exponential regression curve. And so this time we're going to go back into stat and edit. And this time when we ask for the residuals, it's going to be the residuals of the curve instead of the residuals of the line. So L3, second stat, and we'll go down and residual should still be there as an option. And so we're going to fill in that whole column with the residuals. We're going to go back up to stat plot. We're going to turn it back on again or make sure that it's on scatter plot. And we want to make sure that it's list 1 and list 3, which are our x values and our residual values, and press graph. And this time you'll notice that we get a graph that is much more scattered. I have points that are above and below, sort of all the way along, and they're a little bit more randomly spread out, which tells us that the exponential model was, in fact, a better model than the linear model we had before. All right, so we're going to go on to the back of the notes. And in this case, you're going to want to clear your calculator all over again if you're going to follow along and do this one with me, which is a great idea so that you get used to the keystrokes again, since we haven't done this in so long. You may want to start with second memory, go down to number 7, which is reset. We'd want to reset the data, all RAM. Yeah, we want to reset. And now that all of our RAM is cleared, we want to do second catalog to turn diagnostics on. And if you do second alpha and then press the key that has the green D, which is actually X to the negative first, it will bring you to all of the catalog things that start with the letter D, and diagnostic on, very close to the top of that list, and hit enter one more time to make sure that it's done. Okay, so now when you look at your stat edit table, it's blank again. The data that's here asks us to look at millions of barrels of oil compared to its coded year. And what you'll notice, it says create a scatter plot of the data on your calculator and compare it to the sketch above. Treat 1900 as year 0. So 1905, you would actually plug in 1 for your X or for your list 1, and then 10, 15, and so on. So you're actually only using those last 2 digits of the year, not the whole year. And then your list 2, or your Y value, is the millions of barrels. You'll also notice that when you get to the bottom of this list, you have to go up to the top of the next one. There's 2 whole columns of data here. So by the time you get to the end, your last X value is going to be 72. And your last Y value is going to be the 18,584. So just be aware that when you are typing in data, sometimes the data is best presented sort of more compact. But in your calculator, this is going to be one whole list. When you hit 45, the next number is going to be 50, 55, 60, and you will continue list 1 all the way down both of those list 1 columns. And then list 2 will be the whole column, and then a second whole list 2. You create your scatter plot by doing second stat plot and turning it on. You would get this lovely graph over here on the right. Does it appear that a linear model will fit well? We don't even need a residual plot on this one. We know that this is a no. We know it is not linear because we can very clearly see the curve on this one. And we also know that exponential would be a better option because it appears to be following a curve. Using your calculator, determine the exponential regression equation, add this curve to the scatter plot sketch. So you're following the same steps as we did for least square regression line. Only difference is you're choosing option number 0. We are going to get y is approximately, don't forget it's the A 175.17 times the b value raised to the x. We're doing that y equals ab to the x because it is exponential. The R value approximately 0.9976. And if I square that, 0.9952, that curve following very nicely. So that's a good thing. Last but not least, you would also want to make a residual plot for this. After you have done option number 0, which is your exponential regression, and you've gotten all of this information over here on the right on your calculator, and you've graphed it, and you can see that you've got your curve of dots, and you've got a curve that's along with it. You want to change that list 3, remember, to residual. And once you've got list 3, you want to create a residual plot and see whether or not it is coming out scattered. This one is a little bit funky. This one comes out, this is my computer generated one on the left. On the right is the one where I actually had to write it out by hand. So the difference between what it might look like on your calculator screen versus the one that you are graphing yourself. It does go above and below in multiple areas. You can see that there is a little bit of a wave to it, but because it's not, you know, everything's on the top in this section and then everything's in the bottom in this section, we can say that this is a reasonable representation of an exponential model using our graphing calculator. If you need to, don't forget you have that cheat sheet from chapter 4, additional resources for the graphing calculator TI-84 Plus. It will work the same as what we're doing right now. The only thing that's different is instead of option 8, you are choosing option 0.